All right, so home plate for tonight, it's only one function. Once again, graph f of x equals absolute value of x using the domain -2, -1, 0, 1, and 2. Once again, for that part, I do want you to show me the table, and I want you to graph it using a pencil. Tell your neighbor what I just said. So yeah, so I want the table, so you can show the values, and then in pencil. From there, the transformations, listen to this part, the transformations, I do not need tables. I just want to see the graph. Tell you know what I just said. Everybody got it? Okay. So, on a side note, for those of you that are still a little bit iffy with some of these or with the functions, quick note. When we started with functions, we said, I'm going to start you guys off easy, and I said f of x equals something x minus whatever. And this is a linear function. Why is it a linear function? Because if we graph this, it makes a what? A line, a straight line. From there, the second function I gave you was f of x equals x squared. And that's the one that we've been using the most to show the different transformations. This is what we called a quadratic. And what does the graph look like for that one? It's a happy face or a sad face, right? All right. From there, last night, I introduced the new function, which was which one? This one, the absolute value. F of x equals absolute value of x. This is an absolute value function. And the graph is a V. There it is. Okay? Now, let me elaborate as to why it becomes a V. Remember when we did absolute value one variable equations that you needed to do one negative and one positive. Remember that? So that means we had answers on both sides of the number line. Okay? So therefore, if I gave you the table x, f of x, and I gave you the value -5 and -4. What is the absolute value of -5? 5, and the absolute value of -4? 4. And if I continued and I went to all the way to the other side and I gave you the values 4 and 5, what is the absolute value of 4? Still 4 and 5. So the y values or the f of x values don't change. That's why these stay the same. That's why on both sides, it's going to be the same height for both sides of the coordinate plane. That's why we end up with a V. Okay? And lastly, today I'm going to introduce another one, which we already saw before in other years, and this one's called x to the third power, and this is a what? Cubic function. And how does that look? It looks like that. Okay? So for home plate, what do I need for home plate? The original one in pencil with the input-output table. The rest of one, do we need a table for the rest? No, you just need to graph it with those values. Aria, can you get that? Yeah. So this one in green, this one in red, this one in blue, this one in black. This one doesn't matter if it's in pencil or pen in black, but I want to highlight it in yellow. And this one, you highlight it with a different color, either neon green or another highlighter color. So you should end up with how many different colors? About 6 of them, yes? Yes, Mr. Q. All right, good. We got it? Yes, yes? All right. And once again, if you are having problems, come see me at lunch or after school. Hello? Let's see. Ring. Somebody pick up? Ring. Hello? All right, here we go. Our objective for today, I can transform a function using different parameters. I can transform a function using different parameters. So, tell your neighbor what concept we're still on right now. Functions, that is correct. And do we need a Frayer model for today? We got it? Okay, let's see if it's true. Lock your toolbar. without looking at your notes, either write in there or type in there the definition. You got 40 seconds. Ready? All right, so it should, in your noodle, you should already have that, like, pictured in there, yes? You wake up sometimes, you're like, relation. Anyways, so we said it and we defined parameters. What are parameters? They are numbers that transform a function to another function. Yes? All right. From there, I introduced the linear equations, and we said that we no longer use y. What do we use? F of x for function notation. Is that correct? From there, we did the first transformation, and I showed you how we can add a column to that, and we did that. But I said, no, I like it in individual tables, and that's why we did this. Look up, please. Look up to the screen. Look up, look up, look up. So, I want to make sure and clear that you understand what you're looking at. We're looking at these transformations. What do you notice here? That the f of x is by itself, but then a number being added to the whole thing. And here, f of x by itself, and a number subtracted to the whole thing of the f of x. So, this does something, and this does something to the original function. Talk it over to your neighbor, let them know what do these two do. Go. Okay? So, Jasmine, what does the positive number do to the f of x? It increases or it moves which way? It moves up. Hands if you agree with that? Yes? And whenever we have a subtraction, it moves what? Down. So you take that whole function, whatever it is, whatever it looks like, and you move it like that. Okay? So, from there, I had you do one of these to make sure that you got it. Remember that? Yes? From there, I said it gives us the general rule of g of x equals f of x plus k, where k now tells us to go what, everyone? Up or down. Okay? And what's the name of k again? Parameter. Very good, because it changes the function. Then we went to this. And let me zoom in one more time. So now, from the original function, now we have this. What do you guys notice difference on this one? This one has the number inside together with x. So what does that mean, Mr. Q? Once again, that we no longer look at the numbers here on f of x. Now we use what number? The x value. -2 and -5, and then we perform whatever the function. And however, this is going to move the function in one direction and this another direction, so you never which direction shall each one go. Alright, let's see. What does this one go to Allie? Very good. Hands if you agree that this one goes to the right. That is correct. And this one, everyone, to the left. That is correct. And from there, I asked you to do one of these. Yes? All right. So, from there, it gave us this general rule. And we said that the h tells us to either go up or down. I'm sorry, left or right. From there, I said, well, let's combine them, and we come up with this one, yes? All right, so from this one, before I move on, just to make sure we got this, look up, please. And let me clarify. Look up, please. Here it goes. The h tells us to go either left or right. The k tells us to go what? Up or down. Okay. So, some of you are confused as to when we substitute values in here. Here it goes. If I substitute a positive value for h, a positive number, take a wild guess what number I'm thinking about. 23, Michael Jordan. So, if I substitute that in there, what does it look like now with that number substituted? It looks like what? X minus 23. So you're like, minus? I thought you substituted 23. Yeah, it's a positive for the h, right? But what part of the formula? The negative stays there. So what kind of number did I substitute? Positive. So when I substitute a positive number, it goes to the right. Does that make sense now? So you're like, I think I got it, Mr. Okay, well, let me put it like this. I'm going to substitute a negative number. What number am I thinking about? Negative 23. So if I substitute that in here, what's part of the formula? The negative. So what is negative times the negative? So that leaves me with x plus 23. That's why if this is a substitution of a negative, that's where we go to the left. Yes? Or some of you are like, Mr. Pure, I just see a positive number and I go to the left. I do the opposite. Fine. Okay? So with that said, here we go. Lock your toolbar. I'm going to help you with the first row of this one, and you're going to do the last three. So here we go. According to this form that I gave you, the h and the k do something. Is that correct? So here we go. I'm going to start with the h value being a positive. So I substitute a positive number here. Tell your neighbor what direction that's going to go. What direction? Let's see, Pedro, which direction? Right is correct. No, right is right. That is correct. Remember, if I substitute a positive number, it stays what? X minus whatever that number. And what happens if it's a negative? We go to the right. Comma. K. If it's a positive number, tell your neighbor which direction that goes. Everyone. Up is correct. That is correct. So I helped you with the first one. Fill in the rest of them. You got 40 seconds. Ready? Go. Since you said you got it, I just sent you a screen. But I'm going to send you another one. Lock your toolbar. And I want you to graph me it. I don't need input-output tables. Graph me the green transformation, the red one, the blue one, and the black one. You got 1 minute. Ready? Go. All right. So, once again, the black one is on this place because if it's a positive number, that means that we substituted a negative number in there to make it a positive 7. Then it goes to the left. And that's why the other one goes to the right. Okay? All right. Crank it up a notch, yes? Get your graph paper, please. Did you guys get graph paper? Send the gophers, please. They're over here. One per person. So on your graph paper, copy the function f of x equals x squared, and then copy the table in black, in green, and in red. Just copy those. If you want, at the same time that you're copying the black one, fill in the black one. So by now you should know how to do that. Okay. I'll give you some time to copy this. Yes? 30 seconds? No? 40 seconds? Okay, fine. 45 seconds. Go. All right. So I said you're filling in the black one as you're filling it in. Yes? Roman, what is negative 3 squared? Negative 2 squared. And negative 1 squared. 1, 0. And everybody, who notices that after 0, what happens here on the f of x? They repeat, right? So this is 1, 4, and 9. So I'm going to plot those. Yes, let's plot it. Graph our parabola. So this is negative 3, 9, 1, 2, 3. And 9 is up there. Negative 2, 4, negative 2, 1, 2, 3, 4. negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And then your parabola. By the way, this is a quadratic function. Does it make a beat? No, it's a what? It's a curve, right? Happy face. There it is. Okay. Write any pencils down. Look up to the screen. You'll finish copying it right now. There it goes. Please stay focused. Pretty please, with a cherry on top. Here it goes. All right. If I was to give you an expression, look up, like this. What is invisible operation is happening between the 2 and the x? Multiplication. Therefore, look at this transformation. What do you think is happening between the 2 and the f of x here? Multiplication. That is correct. Therefore, with that said, I go to my original function. Here it is. So when x is negative 3, I'm focusing here. What is my f of x? My f of x is 9. But now this is saying to do what? So therefore, what goes here? 18. Fill that in. 2 times 9 is 18. Next, I go to my next one. X value is negative 2. That means I'm going to focus over here at negative 2. But I'm focusing right now on all my f of x's here. Is that correct? Yes. So my next f of x is what? 4. And this is 2 times f of x. So what is 2 times 4? 8. The next one, x f of x is 1. Therefore, 2 times 1 is 2. And the next one is 2 times 0 is 0. And what do we know after 0? They repeat, so it's 2, 8, and 18. Okay, let's graph those. Make sure you use your color pens. Here it goes. Negative 3, 18. 1, 2, 3. 18 is way up here off the grid right there. Next one, negative 2, 8. Negative 1, 2. 0, 0. 1, 2. 2, 8. And 3, 18. Okay, let's get your parabola. Maybe it's not going to be nice and pretty like mine, but try. All right. Look up really quick. So, we started with our original function. Pay attention to this part. Ready? Now, who's seen, look up guys, who's seen, I think they sell them at those science stores. They have these wooden things that have a lot of pins on them or nails. Who's seen those? No? Okay, good. Imagine I give you a board, a wooden board with nails in it, okay? And the nails are every corner of this grid. Like a nail there, and nail there. And I was able to get a rubber band to make this original function. Can you picture the rubber band going from this nail to this nail? Yes? All right. But then I said, okay, guys, now that you have the same one as I do in your board, I want you to take that function and I want you to make this one. So you know what's going to happen to what you have in front of you? What's going to happen to that? What's the word? Stretch. That is correct. It's going to stretch. So, make a note. What kind of number is a 2? It's a whole number. So whenever the factor is a whole number, what's going to happen to our original function? It's going to stretch. Did it look like it stretched? Can you picture the rubber band stretch? You're stretching it to make it a bigger function. Yes. Same function, we just stretch it. And you're saying, I still don't see it, Mr. Q. Well, let me show you. What if I did here, next to here, I did 4 f of x. Let me zoom in. This is 4 f of x. So what does that mean? What is my original f of x? 9, but now it's 4, so what goes here? 36. The next one, 4 times 4 is, so what do you guys notice? That we're going to end up with big numbers. That means the next one over here will be 36, way up here, and then the next one somewhere over here. So what do you guys notice? It's going to start doing what? Stretching. So if we multiply times whole numbers, it's going to stretch. Therefore, let's go with the red one. Ready? Here we go. What do you notice the factor is now? What kind of factor is it? What can you call that number? A fraction. Damn, you guys on the ball today. So, a fraction. What is our original f of x? It was 9 times 1/2. That gives us what? 4.5. Or 9 divided by 2 is 4.5. Next one. 4 times 1/2. What is that, Danica? 4 times 1/2. That is 2. Next one. 1 times 1/2. Victor? 0.5 or 1/2. And then 0 is 0. And what do we know from there, everyone? It repeats. 1/2, 2, and 4.5. Let's graph that, yes? Yes, Mr. Q. All right, good. Here we go. -3, 4.5 is about right there. -2, 2 is right there. -1 and 1/2 is right there. 0, 0, 1, 1/2, 2, 4, and 3, 4.5. So, I hope it's obvious from the original function what happens when we multiply times a fraction. Tell your neighbor, please. Look at it. It was like this, but now it's no longer way up here. It's down there. So what do we call that? What would be a word? Shrink, but we call it in math compress. Compress. Okay? So with that said, to close this off, copy this. We're adding to our rule. Yeah, let's go. Now we have g of x equals a times f of x minus h plus 4. Just to finalize this, what does a do? It does two things. It what? Stretches or compress. When does it stretch? When it's a whole number, and compress when it's a fraction. And we already know what h and k do, right? All right, so your home play for tonight, make sure you focus on that. If you need extra help, be here after school. Tutoring is free. Have a good one, guys. See you guys tomorrow. Bye.